Hello friends, welcome again to Ravi Academy. Today we are going to discuss another topic of chemistry, that is valency. So in valency we have to check few things. Out of these, first one is atomic number. So as you already know that atomic numbers are clearly given in each and every chemistry books, known as Mendeleev periodic table. So from there you can take the reference of respective atomic numbers. Second point which must be noted down is we need to understand the shells. There are particular shells like uh, K, L, M, N. These are all shells. Now you need to understand that in the K shell we can fill only 2 electrons, whereas in L shell 8, M 8, and so on. So we have to fill in the first K shell only 2 electron, and in the next each and every one you will have to take only 8 electrons. Now so next part would be to understand that electronic configuration. Which we have to write like this: K, L, M, and beneath them there will be the respective electrons which we have devoted to each and every shell. Now next part is find valency. So how we need to find the valency? So for that you need to understand that if you have devoted 2 shell to K shell, 2 electrons to K shell and 8 to L shell. Let's take an example. Like for sodium, the atomic number is 11, and if we put the electrons like this, so this innermost shell is K shell, this one is L shell, and respectively this is M shell. So second point says that we need to fill only 2 electrons in the K shell. So for the sodium, here are 2 electrons in the first, now it is complete. Now moving to next shell, we need to fill 8 electrons. Now these are 8, and 8 plus 2 gives 10. 1 is also remaining, so it will come in the M shell. So now you can very easily see that we need in M shell 8 electrons, but here is only 1. But there is one contradiction also. So for that I need to write fifth point, which is if 1, 2, 3 and 4 electrons are in outermost shell, then valency is the number itself. That means if it is 1, then it is 1, 2, 2, 3, 4. So over here for sodium the valency is 1, because in the outermost shell there is only 1 electron. Now I'm giving you another example. So for boron, the atomic number is 5. So this is the symbol of boron, B. So its atomic number is 5. Now we have to allocate the electrons. So 2 will come here in the K shell. How many remaining? 3. So 3 will come over here. Now you can see its valency is 3, because I have written earlier that if 1, 2, 3 or 4 electrons are in the outermost shell, then the valency would be same as it is the number itself. So for another example, you can say we take oxygen. So atomic number of oxygen is 8. So we need to fill like this. So over here you can see 2 are allocated to the K shell. How many remaining? 6. So 6 will come over here. 4, 5 and 6. Now you can see 6 electrons are in the outermost shell. Whether it is L shell or M shell or N shell, it is outermost. So therefore, for this case, you need to subtract the outermost electrons from number 8. So valency will become 8 minus 6, that is 2. So valency of oxygen will become 2. Now understand? Similarly, you can take many examples. I'm here going to give you some other examples of inert and noble gases also. So for that, we take example of neon. For neon, the atomic number is 10. Now we start filling. Now over here in the K shell, 2 electrons are devoted, remaining are 8. So you can see 8 are there, but it is completely filled, because as you subtract this valency from 8, it will come out to be 0. So valency of neon will become 0. So that means it is known as, that is why it is known as inert gas, because it is neither reactive nor it is not reactive at all. Neon. Similarly, argon's atomic number is 18. You can see. One, two, three, four, five, six, 7, 8. So the valency will become 8 minus 8 equal to 0. Again, it is non-reactive. So you can see neon and argon, which are known as noble gases, are non-reactive. Let me rub this. Now one more thing I want to tell you people, that how to write the electronic configuration in case of valency. Now for finding the valency, you need to first understand the electronic configuration. I have written in the third point that electronic configuration must be in the manner of K, L and M. So for take example of oxygen. Here valency, you can see that in K shell there are 2 electrons, and in the L shell there are 6 electrons. So you can write electronic configuration of oxygen like K, L, because we have taken only K and L shell, they are only filled, M shell is empty. So below K you have to write 2, and below L you need to write 6. So this is the way to write electronic configuration. So this is the valency. So let me sum up once again. Valency, to find the valency, you need to find out the atomic number, and atomic number, after that you will have to mark the shells, respective shells like K, L, M, N shell, and you can devote only 2 electrons to the K shell, and L and M shell will take out the position of 8 electrons. And you can write electronic configuration like K, L, and M. Valency, to find the valency, you need to first write atomic number, then you have to allocate like this in a structure manner in the K shell, in the L shell, in the M shell. As you are go on increasing the electrons, you will find the outermost electrons present in the shells. Now fifth point is 1, 2, 3, 4 electrons. This is very important point, that if there are 1, 2, 3 or 4 electrons present in the outermost shell, then you need to write the valency as it is, as the number of electrons are actually present in the outermost shell. So few examples over here are given, like boron, oxygen, and in this way you can write the electronic configuration. I hope this was informative for you people. If you have any problem with the content of the channel, you can tell me in the description box. Thank you very much for the watching.